Hey everyone, today we'll be looking at class variables. So class variables are declared at the top of the class. So what you do is you have your definition here. So we're going to start off with a keyword class, and then we're going to call the class whatever we want to call it. So we can, for example, call it dog2, for example, whatever you want. So you can name it as you please. There is no restrictions. But in this instance, I'm going to call my class dog. So here you can see that the variable called species. This variable is declared right after the class dog keyword, and notice the two colons here. It's indented. It's not like here. You can't put it there because you will get syntax error. So that's not valid. So you have to do the indentation like this because Python is all about white spaces and indentation. So this variable is created here. So what's the difference between this variable here, self.name, and species? So both are variables. The reason is this is a class variable. This is something that's shared with multiple objects. So you do not have to provide what the values should be for the various instances you create. So for example, here I am creating a dog instance of Rex. But if we wanted, we could easily create another one. Actually, before I do that, I just want to show you this. So you can see I've defined a value of wolf. And if I were to run this, you can see the output for that statement here, d.species, is wolf because we have set wolf here. And I can easily change this to, for example, to fox here. And if I run this, you can see now that it has the output of fox. This is because I changed it over there. Notice it's not defined within here. So that's one of the differences. This is an instance variable. So all these self.name, self.age, these are instance, while species is at class level. So it's a class variable. So now what I can do is I can easily create another dog. For example, I'll call this dog2, and then we will name this as Max, and we'll age this dog as a 3-year-old. So now if I were to run this, what you will find is we now have two dogs. And if I were to print the name of the second dog over here, and you can see that its name is Max, while actually for the first one, so if we do another print statement here and do the name of the first one, you can see it's Rex and Max. But if I were to print the name of the species for dog2, so do another print statement, dog2, what you'll find is it's actually fox as well. So if I run this, you can see that the first one, Rex, is a fox, and then Max is also a fox. This is because it's picking up the value from there. Notice one difference is we haven't told it dog1 is a fox, dog2 is a fox. So that's the difference. It's a shared variable between the two instances or the two clones. I hope this makes sense in terms of class variables are declared like this, while instant variables are, they do have the word self.name. So it'll always start off with self, while instant class variables do not start off with the word self. Hello everyone. Today we will look at instant assignments that basically shadow the class variables. So this is important. So here you can see we have a class variable called species. What would happen if you were to create an instant variable called species too? So here you can see, for example, we created two dog classes here, D and D2. So the first dog here, we've given it a name of Rex, which feeds into over here, and you've got the age. So here Rex has the age of 2. Then we have another dog called Max, and Max has an age of 3. So here you can see then I print the D variable here, the D species of that, and we've got D2 here and D2 species. So then we get printed the result, which is Rex is the fox species, Max is a fox species too. So if we look at where it's getting the species part, which is fox, that's actually a class variable. So for example, I can change this variable to be something else. So for example, I can change it to a wolf species. So these two dogs would now, Rex and Max, would be of wolf species. So if I were to run this code again by clicking on this execute cell button, and that's success. So you can see that's done. And now if I do the second one, so execute cell, and you can see now Rex and Max are of wolf species. So the question becomes, if I were to create a variable over here, what do you think will happen? So if I create self.species, so I've created an instant variable self.species, and what we'll do is we will now add in species here, and we're going to make it equal to species over here. And now if we were to change the criteria, so the third argument that we can pass is this one is a wolf, and this one is a fox. So Rex is going to be wolf and Max is going to be fox. So now if I run this again, so execute that and execute this cell over here. And what you will see is you now get the result, which is wolf and fox. This is because we've defined these at the instance level. And now if I were to change the class variable to something else, so here for simplicity, I've changed it to unknown, just so you can see that the instance variable are now overriding the class variable. So if I were to run this again, click here and click there, and you can see that we simply get wolf and fox, but the class variable still says unknown. So the takeaway from this is that instance variable override the class variables, and that's important to understand in Python. Hello everyone. Let's have a look at the accidental class variable shadowing that happens, and you may not realize that it's happening until it's too late. So here you can see that I do have a class variable called species. This species variable is for a class called dog. So dogs might be of a species called wolf, because you can get wolf dog species. And you can see here when you initialize the class, it has the following instance variables, a name and the age. So here, those are brought in when you create the class or initialize the class. The dog is able to speak and the dog is able to say hello, and its name as well. So you can see it says its name. And the other thing that you want to see is I create 2 copies. So this is dog 1, this is dog 2. First dog is called Rex, the next one is called Max. And you can see one is age 2 and the other one is age 3. And then you can see that all I'm doing is for dog 1, dog 2, I'm just printing the species and the name. And then we get the output here of Rex is a wolf dog species, Max is a wolf dog species. So how do you end up accidentally overriding this wolf part, which actually is a class variable? So if I were to run this code, you can see that we get wolf. But what happens when you do this? So when you do, let's do it for the dog 1, which is Rex. Let's add species is equal to fox. So we're going to change dog 1 to be of fox species. What do you think will happen? Will both of them change or will one of them change? So if I were to run this, you can see Rex has now changed to a fox species, while Max is still a wolf species. So what's happening is, behind the scenes, Python is creating an instance variable for species, which is different to the species class variable. And what happens is the execution order for this, or the selection order for this, is it will always take the instance variable. So the instance variable for dog 1 is fox over here for the species, and that's the one it will use rather than this one. So essentially it will ignore that and instead use this one. Remember, Python is dynamic objects, so it will use this one that's been dynamically added on. So this attribute or property you may want to call has been added on and is overriding the default value. So that's why you can see for Max it's still printing out wolf, because for Max we did not select an instant variable, we did not create an instant variable, so it will default to using the class variable. But if we were, so for example, if I copy that line and paste it, and this will be dog 2 and change it to fox, you can now see both are foxes, and that's how you end up accidentally shadowing the class variable over here by using the instance variable over here. Hello everyone. So if we look at where do these class attributes get stored, so here you have a class attribute, and the reason this is class attribute is it doesn't have the word self, but these ones within this function, which is the initialization function. So when you create a dog object and you pass it some arguments here, Rex and the age of 2, so that Rex is the name which goes in here and the age is over here. This is known as the instance attribute, and this one over here, where it's a species, you can see it doesn't have the word self, so it's the class attribute. But where do they get stored? As you know, with Python, a lot of stuff, so if we have a look at this, the initialization method has these underscore and ends with underscore. There is something similar for storing the class attribute and the instance attribute. So for example, if we go down here, you can see we are saying that the first dog here, the first variable is Rex and age of 2, and the second dog is Max and age of 3. And you can see we print the name and the species. But we can do another print statement. So this print statement, what we'll do is we'll say d dot, and you can see you get several options. And one of them is a dictionary one. So underscore, dict, underscore. So what this does is if you were to print this, and if I run this code over here, you can see that we get the name, which is Rex, and age, which is 2. But what you do not see, it's important to understand, is the species, because clearly you can see the species is wolf here. That's what we print over here. So these two elements are not mentioned within the dictionary object for the instance. This is because they are class instances. So they are class attributes. So here you can see that species here is a class attribute, and these ones, name and age, are instance attributes. So now in order to print the wolf here, which comes from wolf over here, what we need to do is we need to do a print statement. And rather than do D, what we'll do is we'll say dog.dictionary. So here you can see that this underscore in the dictionary on the dog class itself versus the instance over here. So if I were to print this, and you can see here, when you print this over here, you get the following output. And one of them you notice here is species is wolf. And then you see the other things such as the dog function for speak is over here, say name is over here, which is a function defined here and defined here. So that's where they are stored. So one of them is at instance level and the other one is at class level. And this is the location for the dictionary they are stored in. Hey there, welcome back. So how do you modify class attributes or variables versus modifying the instance variables? Remember, classes, you can have things which are shared across multiple objects, which are known as class attributes or variables. And then you have instance variables for attributes here. So instance variables are basically, you create, so this is our class, dog class, and we create object out of it and store it in D. And then we've got dog2. Again, it's based off the dog class. So that's the dog class. And that's what we're using here. So here we're creating 2 dogs, one called Rex and one called Max. And then you can see I'm going to print the names of the dog and the species. Now the name, remember, is per instance. So this is known as an instance variable or instance attribute. So they are usually referred to as self.name, self.age, or whatever your variable is called, because that's to do with that particular instance. But the class one is a shared one. You can see there is no self keyword. So how do you modify this? How do you change this? So you might think that you can change the name of a dog. So for example, if I go here and if I actually just, before I do that, let me just run this, and you can see the dog, first one is called Rex and the next one is called Max. But let's just call it Rex2 here. And then what I'm going to do is I'm going to change its name back to Rex. If I go over here and change the name back to Rex over here and run this, and you can see that it does change the name there, and it ignores the fact that 2 is there. So if I were to comment this out, and if I run it over here, you can see it's Rex2. But if I wanted to change its name later on, so rather than at the time of creation, we change it afterwards, we just run this and you can see it's Rex there because the second one had overwritten what was there. And you might think you can do the same thing with species. But if you were to do that, d.species, and let's just change it to fox. And what you'll notice is when you run this, that it does change it to fox, but only for the first one, not what you expected to change it for both dogs. Because this is a shared class variable, we want to change it for both. So rather than accessing a particular instance using these variables, what you should do is you should access the dog class and then species, and then if we say fox, now previously when we run this, you see it only affected Rex, which was in this variable, and it didn't affect Max, which is in this D2 variable. But now we've changed it for the dog, and this is how you access class level attributes or variables. So if I run this again, and you can see now both of them actually have fox. So what we've done is by accessing it via class name, it has overwritten this. So this is how you do it. Remember to do it via the class name rather than an instance of that class through these variables. So you always use class name to modify class level variables, which you defined here. Hey everyone, today let's have a look at passing arguments by position or by naming them, and also by mixing them. So there are 3 ways you can pass arguments. One, which is by the position they're in. And if we have a look at this first one, so you can see here we have a class called dog. In its initialization method, we have the parameters self, name, and age. Now, the self parameter you can actually ignore because in the background, Python will automatically pass that in for you. So the only 2 parameters that you need to worry about are name and age. So here you can see when we start to create an instance of this dog class, we are trying to initialize it. So this is the initialization method, which is executed here. So this init with underscore at the beginning and end is known as the initialization method. So here, when you pass the name Rex over here, this will get allocated to this variable. When you pass 2, that will go into the age. But what you can do is you can actually create another dog. So this is the second dog, and you can actually say, I want to pass in the age first and name second. So here, this is fine. You can swap the order because you are specifically using named arguments here. So you are saying age has to be 4 and name has to be Max. But you can't do the same over here. If you were to move this and name this as 2, for example, and then put Rex over here. So if you did that, then you will not get the right output because you will simply get the 2 as the name and Rex as the age. Now this happens because Python doesn't really enforce date types. So you can basically put anything into age, even text. So I've just swapped this back. So Rex is the name and age is 2. So if I were to run this again, you can see that A appears correctly. You get the Rex as the name, age 2 correctly. So this is known as positional arguments. So these are positional arguments. Here are keyword or named arguments where you can swap the order and it doesn't matter because if you look at this, when we say name is Max, age is 4, correctly prints out Max and age 4. But you can also mix them if you really wanted. So here, the third dog that we're creating, third instance, you can see Lucy is without any name keyword. So we are not passing in named arguments, and age is a named argument. So this works because the first argument is by position, which is name, but the second one is by keyword. So that's why you get this output over here. But you can't do this. You can't put age there and name over here. So you cannot do Lucy over here. This will not work. So when you try and run this, you will get this error to say name had been defined multiple times because it will take the positional 3 there and name have been used again. So this will not work. You cannot mix positional and named variables like this. They have to be in the correct order. So you have to do it like this. The name can be unnamed by position and then age has to be keyworded. But again, you can leave the keyword out if you wanted because it's in the correct position. And just remember, you can ignore the first one, which is self. Hello, everyone. Let's have a look at the parameter types in Python. So here you can see that I have a function for the initialization of this class called dog. And you can see that it takes in 2 parameters or arguments, name and age. There is the standard one self, which is referring to the class itself. So an instance of that class, while these 2 are the ones that we have added in. So here, what you can do is when you create a dog class, so if I say a variable called D will hold the dog class, then I am going to create the dog object. So that's the dog class over here. So this needs to match that. But as soon as I do an open bracket, what you can see is you can see that the name argument can be of any type and the age argument can be of any type, and then it will return a dog to you. So essentially you can pass it, for example, the name could actually just be a number. So here I could pass it number 2, and the age I can just pass as string over here. So if I were to run this over here, you can see that this works fine, and I'll just print the output. So here I've just added a print statement for the name and the age. So if I were to run this over here, you can see what's happened is the age has become Max and the name has become 2 because there's no type checking. That's why when you got the hint over here, it says it can be of any type. But what you can do is you can actually say you want the name to be of string. When you do that, and the age has to be, so you put after the age variable, put a colon, and then type in what date type you want. So in this instance, let's select int. So when you do this now when you create a class, so for example, if I go dog, and now you can see that it says name has to be a string and the age has to be an int. But even this, adding a type hint won't work because it still doesn't enforce it. So although you can, now that you've got a hint to say that the name has to be Max and the age has to be an integer, so like that. And if you were to run this, you can see it's the correct way around. Max is the name, age is 2. But there is nothing stopping you putting in the wrong information. So rather than 2 over here, you can physically key in 2 as in letters, string, and this will still work. And it says Max is the name and 2 is the age. So the moral of the story is Python doesn't use the type hints provided here to enforce these data types. So you can still put in basically anything you want without any problems. But the problem may occur later if, for example, if you use 2 over here and then you're trying to add 1 year to the dog's age, then this 2 over here will not work. So just remember, type hints do nothing to enforce type strictness. People can still put in anything they want. Hey everybody. So previously we looked at type hints. Type hints are added to your parameters over here. So these parameters, name and age, they can be of string type and age is int. But of course, Python doesn't actually enforce it. So when we create a dog class, because that's the dog class over here, it takes in its initialization name and age. You can see that you can pass name as max and age as the string 2 rather than int. So even though when you do a comma and it says it expects an int, but Python does not prevent you from typing in the letters 2 rather than the number 2. So if you were to run this, then you will see the output like this, which is max 2 rather than the number 2, even though there is a type hint to say age must be int. So what you can do is, I've commented this line out, but if I were to uncomment this line out and uncomment this line out, what this is going to do is it's going to use a special method that's built into Python. So this function is going to check is instance. So is age, so that's the age variable here, is this age that's being passed in of type int. So you use a comma over here, and then you can say that you want to pass it an object, which is age. What type of class do you want to check here against? So int here is a class. So that's the class we want to check here against. So we're saying here, if it's not, so the not keyword is going to say, is this an instance of int? If it is not, then we want to use the raise keyword, a type error. So this is something that's built into Python. So this is a class, then it's a type error. And here we can specify a message that says age must be an int. So now that I've activated this, if I were to run this with this, we should see an error. So if I execute this, and then if I execute this, you can see that we've got a type error. This type error is because we raised a type error if we do not get an int. So if we do not get an int, type error is raised. And here you can see the type error message says age must be an int, and then type error here, age must be an int, which is our custom message that we typed in here. So what happened if I type in the number 2? Now notice here, the number 2 is in speech marks, and again, you get an error because 2 in these speech mark or quotation marks is still a string. But if I remove the string, and let's do that, and now run it, and notice that we do not get any errors, and max is 2 years old dog as per the class definition. And this matches that this number over here is an int because it matches age is of type int over here. So this is one method, is instant method to check the class of the type, and if it doesn't match, then you can raise the type error, and this is within your initialization method for the class, which is used over here. So I hope this makes sense and you find this useful. Hello everyone, today I've got an interesting situation, which is this number 2 is actually a string, although it looks like a number 2. So here we have a class called dog. This class takes in the name of the dog and the age. The age has to be int, but remember this one, although the parameter says it will be of type int, Python does not force it to be int. So somebody can, in speech marks, enter the number 2, which in effect Python treats it as a string rather than a number. So for example, I've got some error handling here, which checks is the age that's being passed in over here of type int. So this method here checks if the age is int. If it's not, then I want it to raise an error, age must be an int. So here you can see I put it into the quotation marks, so Python will treat this as a string rather than a number. If we wanted it to be treated as a number, then we have to do it without the speech marks like this. But in this instance, I will leave it like that. And if I run this, what you will see is you'll get an error to say that it's a type error, age must be an int. So this error message we added in ourselves to raise an error if it's not of int class type. So what we can do is we can actually make a false attempt at converting the data type. So I commented this code out, but I will now comment this one out over here. And instead we will try this code that basically what it will do is it will use a try and except. So what will happen is it will try to do int over here is a function that takes in age. Age comes from here. So what it will do is it will take the age from there, and then it will try and convert it into an integer and then assign it to the instance variable age, which is using the self keyword. So we will take out this line here because that's no longer needed because we are doing the assignment over here. Because here, if we just take the direct assignment from there, it will not be an int date type, it will actually be a string. So I will take this line out, and now, whereas previously this raised an error, this time let's see what happens. So if we run this over here and then run this over here, and this time you can see there is no error and it has successfully converted the number 2 as a string over here into an actual number 2, which is an int date type. And then this is the name of the dog, which is Max. So if we try and do like number 2 over here now, this should fail because it can't convert it into an int. So if we run this, you can see that we get the error, which is the value error, age must be convertible into int. This is because we added this error message here, value error, that comes up because it tries to convert the letters 2 over here into a number, an int, but it can't. So then it raises an except statement here, and then we get the value error, which prints out the following message, and that's why you get this error message.